Hi, my name is Emily Pillmore. I'm here with Rebecca Skinner, who's wrote a new Haskell book. Do you mind introducing yourself, Rebecca?
I'm Rebecca Skinner. I wrote a book called Effective Haskell. I'm also a lead engineer at Mercury, where I use Haskell every day.
All right, thank you. For those of you that don't know, my name is Emily Pillmore. I do a lot of stuff in Haskell, and I'm just here interviewing my friend Rebecca, who came out with a fancy new book. And I'm fairly happy to see this book in the ecosystem because it does cover some very interesting parts of Haskell that I haven't really seen up to date in the past 10 or 15 years, even. Um, do you want to get right into talking about the book, or is there anything you want to talk about or plug beforehand?
Let's do it. Let's jump right into the book.
All right, cool. Uh, so the book is titled Effective Haskell. Who is this book for?
When I was writing the book, the archetype of reader that I had in mind was really somebody that is an experienced developer, maybe not a super senior developer, but somebody that's been writing code for a couple of years, probably professionally, but maybe, as like a regular hobbyist working on open source. Somebody that's never used a functional programming language, maybe doesn't know a lot about Haskell, maybe has never even used a statically typed language before, but is interested in picking up Haskell because they really want to build things with it, right? They're not learning it entirely for the intellectual exercise, although I hope that's part of it, but because they want to get things done.
Nice. So keeping it simple and keeping it project driven, I suppose, and then focusing on how to just build stuff.
Right.
Good summary? Okay. Great. Okay. So within that, how does that differ from other books that we've had in the ecosystem?
Yeah. So I think that when I look at all of the material that has historically been out there for Haskell, there's a lot of stuff that I would say is really high quality material, but it tends to fall into a couple of categories. Some of it is, I think, well written material that's out of date, right? It was written quite a while ago. It maybe hasn't kept up with the changing way that we actually write Haskell in the real world. And then there are materials that I think are really aimed at people that are interested in learning Haskell from a more like theoretical standpoint or an academic standpoint. And, I think that a lot of those materials, they're great, right? And they're a really good way for people that learn that way and have that motivation, but they're not for everyone. And I wanted to write the book that I thought would appeal to, people like me, maybe people that are going into Haskell without a really strong math background to start with, but, want to learn the language and feel like maybe they can learn this other stuff through Haskell rather than going the other way around.
Right. So I guess you could say bridging the gap a little bit between beginner and what it would take to maybe read those more complicated books with more theoretical topics.
Right.
Okay. Good. I mean, that's something that Haskell's really needed for a long time. There's often it's often the major complaint I think from people. So it sounds like we've got some good material here. I'm really happy to see this. If you can't tell,
Yeah.
okay, that actually explains a lot about what you cover in the book. Do you want to explain a little bit about what you cover more in depth, and then we can talk about more specific topics?
Well, I guess a good starting place is actually where I think effective Haskell differs from some of the other materials, not just books, but other like tutorials and materials that somebody might come across. And one of those is, I start people off very early learning about some specific like extensions that GHC has added, and really treating those as a core part of the way we write Haskell. And part of the motivation there is thinking about somebody that's going to pick up Haskell in a real project. Maybe they're going to start using Haskell at work, right? They're going to run into a lot of things that you might not come across if you're like starting out with like Haskell 98 or Haskell 2010, right? But these are like a real part of what people need to know if they're going to be effective.
So things like locally scoped type variables and bang patterns and that kind of thing.
Yeah, deriving via is the one that people are most surprised that I introduced so early on. And I would say, actually, I don't see that used incredibly often in the production Haskell that I've worked in, but it's one of those newer things that I think has really high utility, and it does come up. And it just fits so naturally if you're willing to sort of like accept the fact that we're working in GHC's very specific dialect of Haskell, right? Like,
I noticed very early on that you also start people on not using a build system, but rather calling GHC itself to run programs. Could you talk a little bit more about that choice?
yeah, so there's both like a philosophical and a practical part of that. The philosophical part of it is, I think that people ought to understand what their tools are doing, because tools are things that like help us accomplish our goals, right? But ultimately, like, no tool always solves like all of our problems, and understanding what's going on, I think, sets us up better to work through anything that comes up, right? I'm just like really a fan of starting from the bottom and going up. More practically though, I really wanted to avoid overloading people with too much information. Haskell has a reputation for being hard to learn. And I think that a lot of that comes not from any particular concept being too hard for people, but the rate that they come up, right? So I really was trying to be mindful that we're going to like step through and teach like one or two things at a time. And so by the time that we do get to using Cabal and building larger projects, at least the core language isn't so scary. And so it's not such a big leap to add this one more thing.
Okay, that makes a lot of sense. Yeah, I think it's often taken for granted that, whenever you get started writing Haskell, you're kind of just thrown into the weeds with things like purity and referential transparency, and are kind of expected to suss your way through it in a very principled and almost academic sense. But, it's often most people's first interaction with those words, let alone those concepts, let alone those experiences. Because I think it's the only language that I've used that's actually usable in industry, that actually uses these concepts to any sort of effective degree. So
Mm-hmm.
I that's a really good point. I'm glad you did that. So I guess that explains other choices in here, like waiting so long to introduce things like monads or MTL.
A really common challenge that I see people learning Haskell running into is this like, trust me, this will make sense later.
Yeah.
We tend to do that, right? Like there's so many Haskell tutorials that tell people like, okay, we're going to use this do notation here and these like funny arrows, and don't worry about it, right? Like you'll understand it later, just cargo cultivate. And I really feel like that makes people uncomfortable, even if they don't logically realize they're uncomfortable, right? It makes it feel like you're standing on quicksand. And this kind of plays into another really pathological case that I see when people are learning really any programming, anything in programming, but Haskell in particular. And that's I'll pick on monads, right? Like one of two things happens when somebody first encounters monads. Either they say that's too complicated and they like grab their ball and go home, or they say this is the divine truth of how programming should work. I'm going to use these for everything, right? Like neither of these is
really
the right
only
answer.
the two camps.
Right.
That's
And
true. That's true.
so what I really wanted to do was help people build the intuition that this is not like, this is neither too complicated for you to understand, nor is it like this thing that you should really be trying to use everywhere. It's like a tool and it solves a particular problem. And I'm going to help you develop an intuition for what that problem is so that you can see the bounds around where this is a helpful solution and where it isn't.
Okay, that makes a lot of sense. Yeah, it's. I think we're currently, benchmarking at this current day. We're entering into the yearly discussion around monads again in various social media circles, and going, is this actually worth it? Is it worth the trouble? And I think focusing on the problems is is kind of the answer, right? It's a lot of it solves a lot of problems that you see in like mathematics as well as in programming, but in particular mathematics, where it's very difficult to cargo cult the abstractions before you understand the problems that they were built to solve. And oftentimes, as somebody who got their start in math, I've had to go back and read history more than math to try and figure out exactly what I'm looking at if someone introduces a particular syntax or abstraction. Uh, and I think the same thing is probably true of Haskell, right? It's you have to know what we're trying to solve.
Yeah. In my experience, it's true. And like I said, I don't think it's unique to Haskell, even if it has a particularly powerful manifestation in Haskell, right? I think we
Right,
see the same thing when somebody first learns about design patterns and then goes throughout their entire code base looking for opportunities to write a singleton, right?
right, right.
Sort of same energy.
It happened with free monads, I think, a while back, and then it happened with what effect systems and everything. It cycles in 2 to 3 year cycles, so it's been really interesting to watch. But it's yeah, you're right. It happens in other programming languages too, where people. I remember reading the giant, thick 1,200 page Perl book by I think it was Conway, uh, and they introduced dollar and dollar for references and variables, and it was like what is this? I have no understanding of what the domain model is, like what a reference actually is, until later when they explain the rudiments between the two. But then, I've had to have this thing in my head for 10, 15 pages while picking out, various facts about how to use them. It is just overhead. Um, but to that end, I noticed that you cover laziness very early on. Could you explain that approach?
Yeah. So I think there's again this like duality between the practical needs of just um, teaching people things that they need to know early on so that they're not left for too long just with me saying trust me, right? And Haskell is a lazy language, and I think that if you don't address that head on, people just really don't quite appreciate how that changes the way that we think about writing programs. Um, and they run into like problems that are really hard to diagnose if you're just not used to a lazy language. It's surprising what things really take people off guard, right? Like, why did my program let me assign this infinite list, but then it crashed when I tried to like find the last element of it? And then the other side of this is it also, I think, is a really good way of motivating monads, for example, right? So the canonical example of monads is IO, and I'm sure somebody out there is going to like tell me that I'm wrong here, right? But if we
Somebody.
roll with
I
it,
know the person. I know exactly what.
if we roll with it, right? Like a really good way of helping people come to terms with like monadic IO is to go through this exercise of saying like, okay, let's pretend that we don't have this, but we're working in a lazy language. How else are we going to actually have a program that makes any sense at all? How are we going to be able to read a file and then write a file if we have no idea of ordering? And so I think that that was another really strong motivator for introducing it early.
It's a good point. I mean, that's often one of the things that beginners cite as sort of the most confusing. Um, is there any way that you demystified the laziness to some degree, or in some way that was different than previous tutorials that sets it apart?
Yeah, I think that a big part of it is just being very explicit, right? Like there are these sections of the book where, like, much to the chagrin of anybody that's concerned about page counts in their books, I dedicate quite a few pages to really, like, manually unrolling the way that evaluation happens in Haskell.
Mm.
And I think just showing people where there's a thunk and where a thunk becomes an expression, and like where the next thunk is, um, helps people develop an intuition and realize that it's really, like, not that scary in a lot of ways. I think it actually is very natural to the way that most people think about running code, right? Like when we think about the way our programs evaluate, even in a strict language, right? We tend to take the mental shortcut of saying, like, well, and then we call this function, right? Which is kind of a thunk. And then we have to go through the, like, burden of actually unpacking that strictly in a strict language. And so helping people break out of that habit and realize, like, actually the language is letting you think about this in the way that I think is most natural for most people, and really calling it out seems to have worked well.
Yeah, I have heard that a lot of people think lazy, but they expect strict in a lot of ways. There's an interesting debate that goes on about whether or not um, laziness is worth it. And I happen to be yes on that. But it's very interesting to see that a lot of people, or a lot of books and a lot of resources, haven't really gone into as much depth, I think, as yours. The last one that I remember is maybe Parallel and Concurrent Haskell by Marlowe, which was like 2008. But he only really goes into like sprint in GHCI and says, okay, here's kind of how it works, but nothing nearly as explicit or as illuminating. So I was fairly happy to see that.
Yeah, and I'll be honest, some of it's just like me geeking out too, right? I'm like, this is really cool, and I just
It's
want people
fun.
to appreciate it.
Yeah, you can tell like the diagrams where you like show where things are thumped, and like the flow is actually really novel and unique. I'm pretty stoked that somebody is explaining it like this, because I shouldn't have to go and say, to somebody who wants to understand laziness, here, read, purely functional data structures and also parallel and concurrent Haskell, and then read the wiki article on laziness.
Right.
Like, it's good to have it in one place. That's what I'm saying.
If the people that read my book come out the other end of it and no longer think that the first step to making an efficient program is to add strict data as an annotation in all of their modules, then I think I've done one of the things I set out to do.
I think you got that in your book. Thank you. So at least we do that. That's a win right there, right? Skipping ahead a little bit in the book, can you speak more to why you focused on MTL as the main source of effects in your program structures?
Honestly, practicality. We can talk about theoretical benefits to other ways of representing effects in code, but I think in practice, if you go looking at any piece of Haskell code, especially in my experience in industry, but even open source applications, right? It's just far and away the majority case. And I think that somebody going into a code base that maybe is using, say, an effect system, or even like isn't using a tagless final encoding, is just using like straight up transformers, like, you're going to go into that better prepared. I think having gone through an MTL style experience. And there isn't the page count to cover every way that we might do it. So I tried to just give people what I thought was going to prepare them best for the most code that they would run into.
I guess that's a good reason for a follow-up book if you haven't already started.
I
Effective
haven't.
Haskell too.
Effective or Haskell?
More effective Haskell. Yeah. All right, though. Well, we're about halfway through. Do you want to talk about yourself?
Sure. I think that I am less interesting than my book, but I'll give a little bit of background. So, I live in St. Louis, which is really only interesting because we used to have the Strange Loop conference. This was the last year for it. We had ICFP once. So that is, at least to someone like me, the hallmark of the city.
That was actually the first ICFP I ever went to, by the way.
Same, actually. I've been using Haskell since 2008 or so. And I've been trying to be involved in the Haskell community since maybe 2016. So a very long period as one of the many silent people out there just using Haskell and not arguing about monads and effect systems on the internet.
You're calling me out right now. All right. Well, cool. I mean, how long have you been programming, period?
Oh, you're going to make me age myself.
Yeah.
So
I want to hear all about the Rebecca.
All right. So I started programming when in middle school, I got a graphing calculator that had TI Basic, and I had no idea that I was actually programming. I just realized I could cheat on my math homework by writing all the steps out in the calculator. And I took a programming class my sophomore year of high school. I ended up taking AP programming my sophomore year of high school, and just couldn't ever imagine wanting to do anything else. I actually thought before that I would be either a fashion designer or an archaeologist, and I took one C++ class, and that was the end of any other aspirations.
Oh man, we could have had a designer, Rebecca.
Yeah, and so I started my career actually writing C++, really working in sort of quasi-embedded systems and appliances, and got interested in functional programming around 2007, 2008, and it really just got out of hand from there.
I see. Okay. One of the big topics that I was excited to see in the book was the fact that you talk about micro-benchmarking and sort of memory layouts in various capacities using things like vectors, like mutable vectors and non-mutable vectors. Can you talk more about that decision and what you hope people take away?
Yeah, so I think that a big part of my motivation was helping people really internalize the fact that even though we're dealing with a very high level language, right, that is, unabashedly very far away from the architecture of the machine that we're running it on, that Haskell can be a very performant language. It has a lot of flexibility to run well in scenarios where we need good memory characteristics. We need good runtime characteristics. And I think that especially with people who jump into Haskell and don't have a lot of experience with laziness, right? There's a lot of opportunity for space leaks, and people kind of look and say oh, Haskell has terrible memory performance, or oh, Haskell is slow. And I really wanted to point out look, if you're running something that can run at say the speed of like the JVM. You can probably write something in Haskell that has acceptable performance. And so I wanted to highlight that. And I also wanted to show people sort of a tour of really common techniques that at least I use, that I go to first when I'm thinking about optimizing. The other thing I wanted to do was I wanted to show that not every optimization is about removing the things that Haskell does well. So if somebody's going through the optimization chapter, what they're going to see is actually like by far the biggest performance benefit that we get is like using more laziness, right? We're like using laziness to memoize things. And then, as we begin incrementally doing more and more micro optimizations, we see where this sort of like high level, very abstract Haskell plays nicely with the lower level concerns. Like I really wanted to show off ST because I wanted to show how, the types and the type system actually gives us really concrete benefits to performance. Right. And I think that's really, really interesting because people, like for myself, right, coming from a C and C++ background, I wouldn't have really thought about the ways that leveraging the type system would let us do optimizations that we couldn't otherwise do. And then some of it's just for fun.
Types can definitely get us a lot of the way there in terms of establishing the invariants we need to execute certain kinds of loops with certain kinds of guarantees that a lot of the times we take for assumption in like C style programs or in C++ or in Java. I have noticed this in my coding lately as well, where I'm more structuring when I can apply certain optimizations as opposed to really using the type system to nail down a domain, as closely as possible. Really, what I'm looking for is like, oh man, where can I, get away with not error checking in a loop, for example.
Right.
Yeah. So I guess there's a little bit of like there's a power to weight kind of ratio that you want to think about with types and stuff. And I think the benchmarking chapter kind of illustrates it really well, where, we don't always have to drop down into mutable vectors to talk about the most performant thing in the world. Sometimes we can just do the right thing with vectors and let the compiler do the rest of the work.
Right. And sometimes we import the nasty, unsafe parts of the libraries that we really shouldn't be looking at.
Yeah. Every time I've used things like, unsafe, accursed, unutterable IO, or sorry, accursed, unutterable IO, I've always come back like within a year and been like, do I need this? Did I really need this? It's fun to play with, but like, I probably don't need to be that unsafe, right?
Yeah, one of my favorite little Easter eggs is I actually wrote an entire chapter, finished a complete chapter on unsafe perform IO for the book that I ended up having to cut because the book was just too long, and I didn't really feel like handing people that particular very pointy object if I had to pull something out.
That's probably fair. Although, please post it. I would love to read it.
Yeah, I do plan on making it available online as soon as I find some time to clean it up, because I found that it was a really good opportunity to talk about like let lifting and the way that like the compiler reorders things, and why unsafe is actually safe, but only if you understand exactly how your program is going to be transformed. So
I suppose you really have to track your reads and your writes at that point, and just hope you understand. That's the big question. It's like, I hope I understand my program model well enough that it's not going to cause like heap corruption. All right. Yeah. So at the end of the book, we spend all this time in benchmarky, lower level memory layout land, and we talk about concrete projects, and then we talk about, various abstractions you can apply. But there is also a type level programming chapter. Do you want to talk more about why that was included?
I think this is to some extent the most surprising the most surprising chapter for a lot of people, especially people who have been using Haskell in industry, because I find that people frequently say like, well, do you actually ever really use that in production? And I think this chapter is me really talking to people who have been using Haskell for a while. Maybe the people that might be using the book to teach Haskell to, say, like new hires on their team, and really persuade them that there is a space for this, and there's a space for these techniques that fits in well with a very pragmatic style of writing code. I think that there is a real advantage to Haskell in the way that it gives us such a broad spectrum of the ways that we want to interact with the abstractions that we can build, right? We can write like the Haskell 98 style, like very straightforward functional code. We can write code that is using like mutable vectors and unboxed types and really like C with different syntax almost, right? And then we also can write type level code that fits in, I think, well with these other types of abstractions. And so, this goes back to thinking a lot about the way that we can use the type system to enforce invariants, and then have the implementation of those invariants be somewhere on that spectrum of very performant to like very easy to work with. And so I think that type level programming, the way I think of it is, we're writing an application whose user is the programmer that is working with our code. And we're just giving them a toolbox to work with these other more concrete abstractions more easily.
It's a good way of talking about it. I suppose a lot of the time we talk about writing for users, but in a sense, other programmers can be users of our code. It's good to keep in mind. Do you have any other bits of wisdom for people that want to dabble in the type level or dabble in the lower level that you'd like to talk about?
Honestly, in both cases, right, the real answer is just do it, go have fun, fail. You learn a lot from doing. Nobody gets good at writing type level code without writing some really horrendous type level code. Nobody gets good at writing really low level high performance code without like a runtime error here and there, without a seg fault.
Yeah, I've definitely been there.
Yeah, make space for yourself to fail, and that's where the learning happens.
Mm-hmm. Having fun with it is mm-hmm. definitely a good one. I think, while we're here in the interview, one of the things that has really helped me lately in the past, 2 years has actually been a library called event log to HTML, which has allowed me to like do data visualizations on various like heap profiles for when I'm benchmarking stuff. And you can do it with like really small executables, and you can gain so much knowledge so quickly about what your program is doing. Especially just going through the GHC options and being like, oh, I should toggle like -HY instead of like just -L and -AU or something. It's really fun.
Yeah, reading the manual is surprisingly effective, right? Like, people should still read effective Haskell, but you can get pretty far just reading the manual.
I mean, you're not going to understand the thunks like like you get in effective Haskell,
but yeah, I think one of the patterns that you see in the book a lot is really this pattern of walking through something and letting it fail and saying like, oh, this went wrong, right? We tried to do this and it didn't work. Why did that happen? Let's take a step back, think about what's going on, and then try to figure out how we can prevent that. And I hope that somebody coming away from the book really retains that approach to writing code and really does get that sense of curiosity that says like, oh, I'm going to go look for ways that I can understand what went wrong. And rather than being discouraged, look at this as an opportunity to figure out like, what they can do next and how they can build better.
Yeah, I love that. We're very denotational in Haskell. We're like specify first and then write the thing. And if it's not done the first time, then you didn't specify it well enough. But that's kind of counterintuitive and kind of antithetical to the whole ethos of programming, as far as I understand it, which is there's tools for a reason. You want to have fun with it. You want to try stuff. Make the rocks think.
Right.
So now that you've finished up with the book, what else are you doing?
Well, there's the whole second part of now I've written a book. I have to finish writing up solutions for all of the exercises. I'm just about ready to publish. By the time this video is up, most of those should be available at the time that we're doing this interview. I have the first 7 chapters worth of solutions available. There's, errata, and no matter how much you try to not leave out words and use bad grammar in the book, some of it, the gremlins will get in there and make some of it appear.
Yeah, the 3 a.m. writing sessions.
And, after that, I have quite a few projects that I've just really had on the back burner. And I don't know exactly which one I'm going to pick up, but I'm really into this idea now of writing a game in Haskell that teaches people how to program. So no promises, but I'm hoping I'll make some time for that.
I've not actually seen a game in Haskell before. I'll be interested to look out for that.
Yeah, there's a pretty small but active community of people that are writing games in Haskell. So
interesting. What kind of games? Like 3-dimensional, like 2D, like roguelike type things?
Yeah, a lot of like 2D and roguelike. Those seem to be popular, right? They're easy for like the one person to do. I think you have a lot of people like me who have much grander ideas than they have time or capacity to make like all of the art and assets that go into a game. So,
well, shoot, like an RPG maker written in Haskell, that would be pretty cool, and probably not the worst sized project in the world.
We'll see if this ever takes off, but I want to write a Metroidvania, and you get instead of like suit or gun upgrades, you get little fragments of a programming language, and you use that to augment your own abilities using the things that you've picked up. So,
new extensions and functions and stuff.
Exactly.
Like extended preludes.
Yeah.
That's a pretty cool idea. It'd be fun for teaching people. What are your favorite libraries?
Yeah, I'm gonna throw out like a hot take here, right? I'm gonna say prelude or base, right? And everybody's like, oh no, we should be using like
how dare
these
you?
alternative. Yeah, we should be using these alternative alternative preludes and like base as partial functions. It's terrible. Like you should feel bad about yourself. And like I think, yeah, like base doesn't have as many batteries built in as some of the other languages that you might use, but I actually feel like it's a really it's a really good balance between giving you some like good abstractions and also being like, sometimes like partial head, you know what, like it's fine, I trust you. I feel like it has this like sense of practicality that that sometimes people need to be reminded of.
I suppose there's a lot of in the discussions, there's a lot of talk about perhaps like a straw man beginner who might shoot themselves in the foot with things like head. That has never really like rung as true for me. Because usually I like that. Like if I'm ever calling head on an empty list, I really messed up. Like I need to figure out where that bug is, and I probably don't have the correct code there. And I probably want to fix that. It's a very like training wheelsy, incurious way to think about beginners. I don't know. Maybe like some people are just fundamentally a little bit built different. But like, when I was a beginner, I liked it when my programs failed, and maybe that's just the masochist in me. Like, I got started with Perl where everything was failing all the time until it didn't. It was actually nice. Like, it was a good hunt, like a good like thing to do in your spare time. Like, oh man, how do I get this program to work? It's not working.
And I think that as a beginner, you expect things to go wrong, right? You know that you're learning, and you know that things are going to fail sometimes, but you also want to see success. And I think that having you have to deal with like wrapping and unwrapping non-empty lists, or like looking into a maybe every time you take the head of a list, right? Like maybe in like a real production environment, you want that, but I think it really just like drags down. It's like burdensome for people that just want to like get in there, get some code out, learn, like have fun. And that's really, for me, a lot of Haskell is about having fun, right? Like I love the language. I have fun with it. I still just really enjoy all of my time that I get to spend writing code in Haskell, and I want to bring that to other people. And I think that honestly, the design of like Base and Prelude strikes a good balance there for people that just want to like get in there and like have fun and start writing some code.
Yeah, that's fair. That's a beginner take. I tend to agree with that.
I eagerly await the many people yelling at me that I'm like completely wrong and unfit to ever like teach anyone Haskell here.
Oh man, but you wrote a book. You could just point to your book. Like, where's your book? Although some of them have written books, so be prepared. Yeah. No, it's very. I like that hacker mindset. That's kind of what I would call that. It's like poking things to see what breaks, and then adapting accordingly. Like as a former beginner, if I used head a lot, and I don't use head anymore. That's just because I've learned that it's not a good thing to use. But I had to learn that somehow, right?
Yeah, you know what? I still do. Not in like code that I really care if it fails, but there's plenty of times that I'm like, you know what? I just like, I need this thing. And if it crashes, like, I don't care. The only person I'm really hurting is like myself for the next 10 minutes before I never pick this thing up again. And that's fine.
Yeah. My own personal barometer for maturity in my programs is now I just pattern match more often because I can fit a comment in there about what it's supposed to be doing. And it's a little bit nicer than, I don't know, that's just personal preference. But yeah, I think we're at time. It was great talking to you, Rebecca, and congratulations on your book again. And it was wonderful talking with you for the past hour.
Yeah, thanks so much. I really had fun.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.